All right, in 4.1, day 1, we switch gears pretty significantly for our class as we jump into trigonometry, which is where we're going to be for the next 3 units, which is going to be about 3 months. It'll go well into second semester, okay? We've been kind of a functions, that's what we've been doing for the first 3 units, and we're switching gears. Couple things about chapter 4. It's fairly long, so it's split up into 2 tests, 4A and 4B. It splits up really nice, 4 sections each. The first 4 kind of have this theme of some of the basics of trigonometry, getting to like the sine and cosine functions, but we don't get into what their graphs look like or how we make them. Okay? The second 4 sections get into that. What I'm going to talk about to start with is really a pretty natural starting spot. What's an angle? Okay, I know you know what angles are, but I just have some terminology that I want to review with you. This first side that always is placed in the same spot is called your initial side. Okay, it always sits on the x-axis right there. It never moves. Depending on the angle that we have, this other side which is called the terminal side, that moves all the time because it's that second side being able to move it that determines how large your angle is. Okay? If you were to open this way, which is technically counterclockwise, okay, but you don't have to think about it that way as long as you recognize that, it's that way, kind of to the left, sort of, okay? Because remember, we'll always start from that initial side. If that's the case, you have an angle that we would call positive. If you open up counterclockwise and go this way, that is a negative angle. And that's a big thing because you'll see both come up right away. Even in today's lesson, we'll see positive and negative. Last thing I want to kind of throw out there is, just so you're not thrown off when you see them, angles often get names, kind of like variables or unknown numbers. Think of like, X is the most common name for an unknown number. I only bring it up because angles typically get Greek letters. So you have beta and alpha, theta, phi. You don't need to know the names, right? Just when you see those symbols, it's good to know them so you can refer to them. But when you see those symbols, it's just talking about an angle. Okay, maybe it could be a measurement for an angle that's not known, but that's what those are all about. All right, let's talk about radians. Okay, we'll get to degrees in a little bit, but I want to spend a little more time on radians because it tends to be a bigger deal. Okay, the first thing I want you to be focused on is when I say radians, it's an angle measurement. Think of it like units, okay? Think of it like units. Degrees can measure an angle. It tells you how big or how small the angle is. Radians do the same thing, it's just a different unit. Okay, they're defined like this. That we take the length of the arc, which is S, and we divide it by the radius. Okay? Now I'm going to try to draw in an angle here that's about 1 radian. Here's R. Here's S. Okay? Worth putting a note in there that S is the arc that is formed. Okay, if this is angle theta, right here, I'm talking about 1 radian if my arc length S is the same as R. Okay, that's what we would call a radian. Now, one of the really tricky things about them are radians can be really hard to visualize. Okay, now a lot of times we work with radians in terms of pi. Okay, because they're largely based on pi because they're really about a circle. Okay, but let's say this. I'm going to put a new angle on here, and let's say now I'm going like this, and this is S. Okay, it's much bigger. Notice a bigger angle makes a bigger arc. Okay, let's say that arc that I drew in is now twice, let's say it's twice as long as R. If that would be the case, I'd have an angle that's 2 radians. Okay, it's 2 radians. I'll get to more conversions later, some of the ones you'll want to know. But this is where everything starts. If you're talking about 1 trip around a circle, 360 degrees is the same as about 2 pi radians. Okay? It's worth noting, and again, we so often talk about radians in terms of pi that they're hard to visualize. 2 pi is like 6.28. Okay? So they are really, really different measurements. That in an entire circle you have 360 degrees, but in terms of radians you only have a little over 6. Okay, now if you want something to come back to that is something that's going to help you with your intuition and kind of visualize radians, this is just an approximation. Okay, it's not exact, but that is about the case. Okay, 1 radian is right around 57 degrees. Okay, right around 57 degrees. That can help when you're trying to visualize how many radians you have. All right, coterminal angles are when, I'm going to add a definition to this, you have the same initial and terminal side. Okay, you have the same initial and terminal side. Okay, now if we're talking about radians, finding coterminal angles is not super hard to do. 2 pi is the number of radians that are in one circle. You can add or subtract 2 pi as many times as you want. The angle that you're talking about is going to look the same. It's going to be 2 different angles, but their initial and terminal side are going to look the same. Okay, let me show you what I mean. I'm going to do a few of these. Let's say I have the angle of 13 pi over 6. Okay, now I could do either one, but I'm going to take away 2 pi. Notice I took away 12 pi over 6. You'll see a lot of times radians are talked about in terms of pi, and they can show up as a fraction, so common denominators come up quite a bit. Usually the denominators that we work with aren't bad. They're like 2, 3, 6, maybe 5. Not really that bad. Now if I'm talking about radians, okay, and I'm not really that worried about it yet, just because it's something we'll work on. But I know at this point it's probably a bit hard for you to visualize what quadrant you're in. We'll talk about degrees in a couple of slides, and you'll probably find that it's a lot easier for you. If I said, like, you have a certain degree measure, what quadrant are you in? Like pi over 6 is in quadrant number 1. Okay, and if you're like, I would not have known that, that's really what section 2 is about, to kind of dive in to working with radians more. Okay? But notice, here's our initial side, and there is our terminal side. Okay? Now, I showed here from subtracting 2 pi that those two angles are coterminals, meaning if I graph them, they look exactly the same. So now to get to 13 pi over 6, what I have to do is what I like to call a loop-de-loop. Go all the way around. Okay, so it's like you go to pi over 6 and then do another trip around the circle. Okay, now if you go straight to that angle, you're talking about pi over 6. If you go to it and then do another loop, you're talking about 13 pi over 6. Okay? But if you're just looking at the initial and terminal side, they're in the exact same spot. Okay, so they wouldn't necessarily look any different. All right, I'm going to erase that one because I want to do another one. I don't have any more space. You can just, draw another set of axes. But I had to get rid of mine. All right, let's go to another one and say we have 3 pi over 4. Okay, 3 pi over 4. I might actually draw it right away. 3 pi over 4 is over in quadrant number 2. And again, if you're like, really? It is? For today, that'll become important eventually, but for today, just go with it. I'm going to add 8 pi over 4, which is 2 pi in disguise. And I get 11 pi over 4. Okay? So if I'm talking about 11 pi over 4, I go to that angle, and then I need to go around again. And that angle would be 11 pi over 4. Okay? But notice that terminal side that I drew, it didn't move, because for those two angles, it's in the same spot. Do you have the angle that goes straight to that spot, or did you do another loop? Okay? And if we wanted, we could do another loop and another one, and it wouldn't matter. You would still, those two sides would still be in the same spot. All right, I'm going to get rid of that one. And then we're going to do one more that's got a slightly little different component to it. Nothing major. Let's take our first look at a negative angle. Okay. Initial side doesn't move. Negative 2 pi over 3 is down here in quadrant 3. Okay. Now, any other angle that has that same initial and terminal side is what we would call a coterminal. I'm just going to find one of them, and I'm going to do it by adding 2 pi. Now here, this gets interesting because it switches from a negative angle to a positive, which means I am going the other way. The terminal side is in the same spot. If you want to take the negative route to get there, okay, that would be negative 2 pi over 3. Or if you want to go the opposite way and take the positive route, that would be positive 4 pi over 3. But that terminal side is in the exact same spot, okay? So a big idea is that the sides are in the same spot. To get coterminal angles, add or subtract 2 pi. Again, I made the assumption we're working with radians the whole time, but that's how you get them. All right, complementary and supplementary. I'm going to bring this in a little bit. A couple short definitions. If you have two angles that are complementary, they form a right angle. So I could draw, a terminal side anywhere on here, and I have alpha and beta that would be complements. Now if I'm talking supplements, that's two angles that form a line. Let's say it's right here. Then I'd have this big angle beta and this little angle alpha. Okay? Really the only, so that's a big idea to know. But the only other thing I want to do with it is to say All right, here's an angle in radians. Find its complement. Okay, find the angle that I could pair with that one so that they would form a right angle. And here's how it would be done. Take away from pi over 2. Now, I talked about some of the references for angles that are in radians. Pi over 2 was one of them, all right? And that might be one from studying some trigonometry in the past that you're familiar with. That's the same as 90 degrees. Okay, so if we're talking radians, a right angle is pi over 2. So I want to start with that and then just take away the angle that I have. As is typically the case with radians, common denominators just consistently show up. Here I got to use 10. And there is 2 pi over 5's complement. It's pi over 10. Okay? That angle paired together with that angle will form a right angle. Okay? Now let's jump over to supplements. Okay? And let's say if we can find the supplement to 4 pi over 5. Okay? 4 pi over 5. Might have figured this out already. Really, really similar process, but instead of pi over 2, which is a right angle, we want the angle that forms a line. You probably have that associated to 180 degrees, or pi. So here we just subtract it from pi, and we get pi over 5. Okay, we get pi over 5. So that angle with that angle, together they would form a straight line. All right, I don't want to spend a ton of time talking about degrees, and where I want to take this is to get into the conversions. You know, we don't have tons and tons of stuff we need to talk about here, because you guys probably have a pretty good sense of degrees. Sometimes they're valuable to work with, sometimes radians are better. Okay? It's really important for us in trigonometry that we're just comfortable with either one, because we want the option on any given problem that we can, you know, do whichever one we want. All right? So now this is what I was saying about the quadrants, right? With 1, 2, 3, and 4. At this point, if I said, hey, where is 5 pi over 4? You know, who knows at this point if you could get the right quadrant that it's in. That'll become a big deal later on. Degrees are so much different, because if I said, hey, you have an angle that's 210 degrees, well, that's down in quadrant 3. Okay, it's a little bit bigger than 180. That's a lot easier to do. Okay, so what I want to get into now is a better list of conversions. Okay? Because that's what we're going to finish with on the next slide, is just doing some conversions. All right? Now, if we divide both sides by 2, we get to really one I'm going to highlight because that's our favorite. If we're just, you know, going through the process of converting one to the other, that's the one we're going to use. We could divide by 2 again, and we get to another one that we've already talked about today. 90 degrees is the same as pi over 2. Divide it by 2 again. 45 degrees is pi over 4. Okay? Now, if we divide by 2 again, it gets us to 22.5. Sure, that would be pi over 8, but I don't want to get into decimals. Go back to 180 and divide it by 3. This is one that you'll see come up. 60 degrees is pi over 3. Go back to 180 and divide it by 6. You'll also see that one a little bit, that 30 degrees is the same as pi over 6. Okay? That's a good list to keep track of because you'll see those a decent amount. More than, you'll see other angles and radians, but you'll see those the most. Okay, so let's finish today with just doing a few conversions. Okay? First off, let's talk about if we're going from degrees to radians. Okay, you need to multiply by pi over 180. This is something I find that from your experience in trigonometry that most students are pretty good at, and they very quickly remember how to do this, and they're pretty good at converting. If we're going to degrees, it's 180 over pi. Okay. If you feel like you wouldn't remember those, put them on your note card. If you do want a way to remember them more quickly, I always think about it as the one you're going to, as far as what you multiply by, that unit should be on the top. So if I'm going to radians, pi should be on the top. If I'm going to degrees, 180 should be on the top. All right? So let's split this in half here. Let's just do a few. Everything on this left side is going to be degrees. In fact, I'll write all three of them out. So we're going to do 3 of each. You can feel free to go ahead if you're feeling confident with these. Things are going to switch over here a little bit because now these are going to start in radians. Here's E. Let's convert 9 pi over 2. And then F, we'll just convert 2. Okay? These are all going to be pretty similar. There is a certain element of repetition that I'm going for here that, getting good at these. Part of it is just do lots of them, right? Then you get to the point you can do it without even thinking about it. One thing that'll come up a lot is you very often are left with answers that need to be simplified, right? Because the first thing is just to multiply by pi over 180. And then we're not going to leave it as, 135 pi over 180. Rather, we take out a factor of 45 and reduce it down to 3 pi over 4. Notice when I cross that equal sign, I'll show you the same thing on this one. I started with a degree symbol, but as soon as I apply the pi over 180 to the fraction, notice that it's gone. Because even though my answer hasn't been reduced, once I'm at 540 pi over 180, I'm now in radians. Because all that's left to do is just simplify it, and that would be 3 pi. Here we have a negative angle, and the point I want to show you here is that doesn't change anything, right? You can take the approach that if you start with a negative angle, even when you switch units, your answer should still be negative. We should never see the sign switch. You've got a negative sign out front, but other than that, it's the exact same process. So here I'm going the other way, and notice things change a little bit. Okay, you'll see this quite a bit. That the pi's cancel. Radian angles often have a pi in them. And again, a lot of times we're left with simplifying. Okay, and now make sure that final answer has a degree symbol because we've switched over to degrees. The same thing here, cancel the pi's right away. 9 times 180 over 2. It's kind of nice when that pi symbol is out of there. Just a little bit of number crunching left to do with it. This one comes out to be 810 degrees. Now check this one out. This is another slightly different one that I want you to see because sometimes people make some mistakes on them. You know, if we say 2 radians is what we have to start, we don't mean 2 pi. Okay, 2 radians means 2 radians. Okay, 2 pi means almost 6.3 radians. All right, a lot of times radian measurements have pi in them, but they don't have to, and other times they don't. So now we end up with no pi's to cancel, and we get something that looks a little odd, 360 over pi. There's no good way to deal with that denominator of pi. So if you don't, if that happens and you don't have the pi's cancel and there's no good way to simplify it, that's a case where just take 360 over pi, put it in your calculator, and then we'll just take a decimal approximation. That's about 114.59 degrees.